friends, welcome to Scholarate. So in this video we will discuss the applications of trigonometry in our daily life. So in our previous videos we have discussed the way to solve some numerical problems, the basic concepts of trigonometry. Now we will face some real life problems and we will try to solve them by using trigonometry. So in my first video of trigonometry, I have already discussed that trigonometry has innumerable applications, not only bounded to mathematics, but also has many applications in various other branches of science, like engineering, physics, astronomy, and others. In mathematics, or basically in today's video, we will discuss how we can apply trigonometry to find the height of a certain object, okay, or the distance of a certain object, and so on. So basically we have to calculate the height or distance from certain object or observer, we can also say observer. Now let's move on to some terminologies regarding this chapter. First is line of sight. So what is line of sight? The line of sight is the line drawn from eye of an observer to the point in the object viewed by the observer. So is the definition. Now I'll explain to you what is line of sight. So if here is an observer, okay, so observer. Now at this point the observer is located. Now this is the ground position, okay, so we have to take some reference, so it will be the ground. Now let us assume that there is some object. Let us assume it's a tower. It's a tower having some tip over there, some antenna or tip over there. Now if the observer is looking at the tip of the tower by this line, then this is the line of sight. This is the line of sight. Okay, so this line is basically the line of sight by which the observer is looking at some object. Now let's see the next terminology. Okay, angle of elevation. So what is angle of elevation? When an observer is on the ground level, it's viewing some object above the horizontal level. The angle formed by the line of sight of an observer with the horizontal line is called angle of elevation. So I'll explain you what is by the help of the diagram. So in our previous diagram we have discussed that this is the line of sight. Okay, so in this diagram the observer is in the ground position. So the angle formed by the line of sight, that is this line with the horizontal level. So this is our ground level or horizontal level. So basically this angle is our angle of elevation. So this is the angle of elevation. So it's very easy. When an observer is at the ground level, he is just looking at some object in the sky level or is looking something upwards from the ground level. The angle formed by the line of sight of the observer and the horizontal level is called line of sight. Now the last terminology is angle of depression. So when an observer is looking down to an object, so basically in this condition the observer is at some higher level, that is above the ground level. He might be on the roof of a tower or roof of a building and watching people or some objects on the roads. So basically he is somewhere above the ground level and he is looking the objects in the ground level. So the angle formed by the line of sight with the horizontal line is called angle of depression. So let us see. So we have to draw a new diagram over here. So this is some object, monument or some building, and this is our ground level. So let us assume that the observer is here. Here is our observer. Okay, so here is our observer, and here is some object on the road. So the observer will see that object like this. So this is again our line of sight. Now the angle formed by the horizontal line with the ground level, that is this one, this is our angle of depression. He is looking downwards, so this is our angle of depression. So this is our angle of depression. Now we have came across all the terminologies regarding this chapter. Now let's solve some problems in order to know how to use the concept of trigonometry to apply in this real life problems. In problem number 1, we are given that a boy is flying a kite on ground level. So it might be on the roof of the tower or roof of the building, so but it's not in that case. In this case, he is flying on the ground level. The string is stretched tightly. If the length of the string is given, that is 20 meter, and the angle made by the string with the ground is 30 degree, find the height at which the kite is above the ground. Okay, so in this type of problems we have to visualize the problems, that is how the situation is happening in the problem, and we have to imagine that in our mind, and we have to draw some diagrams which will easily help you out to solve the problems. So let us draw a new diagram. So at first draw the horizontal line. So this is the horizontal line or the ground level. Okay, so the boy is situated here, I think, in the ground level, and is flying some kite. So it will be like this. We all know that kite can't fly directly perpendicularly uprighted, so it must be some inclined. So he is flying the kite over here. So here is our boy. So here is the boy, and here is our kite. So the length of the string is given already. Okay, now what we have to find? We have to find the height at which the kite is flying above the ground level. So let's mark the points. So I have already marked the points, and what we are given that this angle is how much? It's 30 degree. So here I am writing 30 degree, and the length of the string is given, that is the OA length is given, it's 20 meter. Now what we have to find? We have to find the height at which the kite is flying, it is this one, the AB, height of AB we have to find. So you can see over here, we always need to draw some this kind of diagram, that is we have to visualize all the diagrams with respect to right angle triangle. It will easily help you out. Okay, but it's not always possible to draw a right angle triangle, so it will vary according to the problem. We will see on later on. So what we'll have to do, it's a right angle triangle, and this side is the hypotenuse, we all know. Now 30 degree angle we are given, it's the angle of elevation we can say, because the boy is standing on the ground position and it is the angle of elevation. Now we have to find the perpendicular, because with respect to the 30 degree angle, this is the perpendicular. Okay, this is the perpendicular. So Now we can apply trigonometry after analyzing the problem. We have to find the perpendicular. We are given the hypotenuse, so we have to find some relation with perpendicular and hypotenuse, and we all know that perpendicular by hypotenuse is basically sine theta. So here the angle theta is given already 30 degree and its hypotenuse 20, so we can easily find out the perpendicular. But we can't directly go like this, we have to follow some steps and then we can move on to the problems. So how to solve it, let's see. First we have to say that OA is the string of the length of the string and AB is the height of at which the kite is flying. And what's the angle? It's AOB, it's already given. Okay, so we just write 20 meter beside this. So this angle is given how much? It's 30 degree. So what we'll write in right angle triangle AOB. So sine 30 degrees is how much? It's perpendicular by hypotenuse. So what's the perpendicular here? It's AB and hypotenuse OA. Now what we have to find? We have to find AB. So AB is how much? It's OA multiplied by sine 30 degree. How much is OA? OA is okay 20 meter. So 20 multiplied by what's the value of sine 30 degree? The value of sine 30 degree is how much? It's 1 by 2. So here we have to know the standard values of trigonometry. So what's the final answer? AB equals to 10. So the height at which the kite is flying above the ground is 10 meter. So it was a very easy problem. Okay, so I took this problem so that you can understand the basic concepts of applications of trigonometry easily. Now let's take a little bit complicated problem. Okay, so what you have to do, you have to follow this type of order to solve the problem. It will be very neat and tidy work if you mention all the variables over here and their dimensions and their lengths also. Now this is the last problem for today. So what we are given, from a fixed point on the ground, the angles of elevation of bottom and top of flag post are 45 degree and 60 degree, standing on a 20 meter long building. Okay, so calculate the height of the, sorry, its question is wrong. it will be calculate the height of the flag post. Okay, now it's correct. Now we are given a problem where there is a building, its height is 20 meter, and it's given that above the building there is a flag post, and someone is looking from the ground level, and the angles of elevation to the bottom of the flag post is 45 degree, and to the top of the flag post is 60 degree. So we have to find the height of the flag post. Okay, so now we are given two angles of elevation and we have to find out the height of the flag post. Now let's imagine the diagram and draw it. So this is basically the building. This is the ground level from where we have to measure all these things. Now there is a flag, okay, some flag post over the top of the building. The height of the building is already given, it's 20 meter. And we have to find this portion, the height of these portions. And what we are given? We are given the angle of elevation from a fixed point on ground to the bottom, that is this one. It's given 45 degree. And what we are given? We are given the angle of elevation to the top of the flag post is 60 degree. That is this one, the bigger angle. It's 60 degree. So we have to find the height of the flag post. So let's mark the points. So it's given that we have to find the CB, that is the height of the flag post. So okay, so now what we can do? First, just forget about CB. Okay, let's concentrate on this right angle triangle, that is AOB. So in this right angle triangle, what we can do? We can apply trigonometry to find the base length, that is OA. Now what we can do? We are given the angle is 45 degree. Just be careful, it's not 60 degree. It's the 60 degree is the angle for the bigger one, that is AOC. But for the right angle triangle AOB, the angle is 45 degree. Now theta angle is given. The side adjacent, that is this one, it's our base, and opposite one is our perpendicular. So basically 20 meter is the perpendicular. So we have to find some relation between perpendicular and base. So we know we can apply tan theta. Tan theta is basically how much? It's perpendicular by base. So we will get the length of this base. So let's write. Okay, so we are given two angles of elevation, that is AOB. AOB is how much? 45 degree. Now we have to find the height of the flag post. But first, we need to find the base, that is OA. So in right angle triangle AOB. So we know that tan 45 degrees how much? It's perpendicular by base. So what's the perpendicular here? 20, and the base is OA, that's unknown. What's the value of tan 45 degree? It's 1, and we have to find the value of OA, that is the base. So the base or the baseline length is also 20 meter. Now what we can do, we've got the base 20 meter. Now we will take the bigger triangle, that is CAO or AOC. So we have assumed the CB length, that is CB BX. Now you can see over here that right angle triangle AOB and right angle triangle AOC shares the same base, that is 20 meter. So we can apply this 20 meter to find the height of this one. So what we can do, the right angle triangle AOC, the perpendicular is basically the summation of AB and CB. So AB is how much? AB is 20 and CB is how much? It's X. We have already assumed it. Now base is how much? Base is 20 meter. We have already found it. And the angle is basically now 60 degree. Now we have to find this one, that is the unknown X value. So what's the value of tan 60 degree? It's √3. Okay, now next what we can do is we can simply split the denominator part into two parts. it will be how much? It will be 1 plus x by 20. Now, so we have to find the value of x. So that is our final answer. In some problems we are given the value of root 3. Okay, so if you put the value of root 3, in some of cases we have to given the answer at this stage only. We don't need to write the value of root 3 and then evaluate further. Okay, so but we can find the value of root 3 and can evaluate it further. So here I have written the value of root 3 is how much? 1.732. You can memorize it, or it's sometimes given in the question also. So what will be the final answer over here? Okay, it's 14.64. So it's not the exact value, it's somewhat approximate value, 14.64. So the height of the flag post is how much? It's 14.64 meter. Okay, so we are ending our video here, and this is the first part of applications of trigonometry, and we will bring some more problems in our second part, where we will do some more complicated problems, and we will try to know how to apply the trigonometry concept in these real life problems. So thank you so much and stay tuned. Don't forget to like, share and subscribe our channel. We will bring some more concepts and more topics regarding mathematics and some other subjects. Thank you.